We're going to get to the code side of what we were talking about before lunch, which is EDA. Before we get into the code, I want to open up and offer any specific questions, burning questions, comments that y'all would like to talk about or share before getting into the code. Anything that you wanted to bring up before lunch and didn't have the occasion? All right, cool. Let's rock. So let's get into the code. My notebook that I'm running is literally the curriculum, so all of this is copy pastable. What I'm doing with this import warnings and warnings.filter warnings, that's suppressing those pink warning boxes. They're not errors, but they're warnings that are saying, hey, something's changing or will change about the Pandas API, which shouldn't matter to you because you haven't been using it for its entire life, right? So we just suppress those warnings. We'll pull in Pandas, Matplotlib, NumPy, Seaborn. We're going to pull in SciPy for some of our statistical tests, and then pull in train test split from sklearn. I think I see a question from Kate. Go ahead, Kate.
Yeah, I already have a question. So on that warnings, is that going to affect these functions running in the background to get your data frames? Or is it just like a pretty print kind of thing when you were presenting out of Jupyter Notebook?
It's a nice to have but it's not going to change any functionality of the code. Now, so what's going on with those warnings is those warnings are saying, hey, some functionality in this library will change in the future. But it's when we look at those warnings aren't anything that are going to turn your world upside down. Yeah.
I mean, I guess that's why I left them on, because like append, we're now using concat, but we were using append, and append is deprecated in the next version of pandas. So I guess to me, I was like, I kind of want to know, but it doesn't matter though, from a functional perspective, you're saying.
I like knowing if something's going to go away, but also I'm of the opinion that you shouldn't change your software too much and remove features. But that's just me. Yeah. Cool. So we're going to do our happy little imports here. And to keep things simple for this explore lesson, I'm not calling any acquire or prep. All the acquisition, the prep will occur in this notebook, so everything's evident and we don't have to share extra code with it. Okay, so the import env, this is assuming I have an env file, which I do, and get ignore is going to create that connection string, and we've got a happy little get Titanic function. Now, something that might be new to y'all, and I want to introduce you to a new friend called isNA. isNA does the following. It gives you a Boolean answer for every column if there's a none value or a nan value. So check this out. On the first record, this 22-year-old male, third class, $7 fare. See how the deck says none? If we look at the data frame produced by isNA, the deck shows true for isNA. So isNA will work on an entire data frame. It can also work on a single specific series. And because our arrays of Booleans are the keys to the castle, as I've been repeating for a couple of weeks now, what we can do is we can sum all of our nulls to get us a null count per row. So we see age is missing some stuff, deck is missing a lot, embarked and embarked town are missing 2 values. So we can slap a .sum on the isNA. Also, what I like to do, especially before trying to determine how I want to handle these, is get a proportion with .mean, isNA.mean. And this gives us the number of missing values per column. So if age is missing 20%, we need to figure out, are we going to drop that? Are we going to fill it with a median? Maybe age was missing because they were a toddler. Who knows? But we'll make a best guess. And deck is almost completely garbage. Almost 80% of that column is empty. So we're totally going to drop the deck column. And then with the embarked town with 2% of a percent missing, we could probably either drop those happily or fill those in with maybe the mode. And that new friend again is isNA. We can call isNA on the entire data frame or a series or column. And Sum gives us the sum, mean gives us the proportion of missing values. And that's a lot of good. That's a very powerful function. And it will help you find your nulls. So looking at what I'm going to do to prepare, I mean, this is, you've already done this. I'm going to drop the deck because it's garbage data, drop the rows where age or embarked is missing. I'm going to be very blunt in this. Y'all have already done the prepare, right? Drop passenger ID since it's providing no new information. Drop class because the encoded values are in P class. And I'll create some dummy variables for gender and embark town. Maybe on a second draft, we might investigate a little more deeply what we want to do with age other than just drop those rows willy-nilly. Adam went through yesterday on how to use the simple imputer. And if you got real fancy, you could make age your target variable and build another algorithm to predict that. So I'm going to make a happy little function, prep Titanic. All I'm doing at this point is catching up with your work, right? And then this train validate test split. This function right here is great because I don't want to have to type out two different train test splits and split to get train, test, and validate. So hang on to this little function for later. And what's going on when we have 1, 2, 3 variables assigning to the result of a function? Notice the function is returning 1, 2, 3 variables. What's going on there is something called a tuple unpacking, which sounds fancy, but all it means is if your function returns one thing, return one variable. If your function returns 2 things, assign 2 variables. Okay. And then we'll take a look at the shape. And we've got 12 columns in everywhere. And we've got the lion's share of the data is in train. And yeah, I've got a question from Fred. Go ahead, Fred.
Hey, Ryan, I see under the train validate test split that that it stratifies along, specifies the target variable. Do we manually input what the target variable is?
Sure, I'm saying that right here
okay,
in the argument. So this train validate test split is not baked in concrete to Titanic. That's why I say, hey, grab this, copy it, save it in a util.py file, use this later, because you want to stratify any categorical target variable, stratified by that target variable. Because of the randomness involved in the train test split, we don't want to unintentionally get a lopsided data frame. So if we were to take a look at, because of the stratification, the proportions of train dot survived dot mean, that should be a very similar proportion to validate dot survived dot mean, which should be a relatively similar proportion to test dot survived dot mean. About 40% all around. That's what stratification is doing. It's making sure that we don't have unintentional randomness, because there's totally randomness in train test split. It's shuffling and randomizing and then plucking out these values, specifically so we don't see signal in the noise. But stratification is saying, keep it balanced. The only time where we're not going to do stratification is when we are working on like a regression problem where we don't have a continuous, where we have a different target variable that's not categorical. All right. I realize that this was a bit of a review, but I do want to open up for any questions about the new stuff like is an A or, and even the stratification is kind of new. So the floor is open if you have questions before we get into the Explore. Lincoln, what do you have?
Further into like is an A, are we going to do stuff with it or is better? Because
that's it.
I think we were having some issues. I was having some issues, and I just asked Andrew today.
Yeah.
I think what we were having an issue with is like trying to change the nulls into a float, or like into yeah.
That is going to be a different method called fillNA. .fillna. So isNA gives you a Boolean answer if we have a missing value in an array-like object. This could also be a NaN for a numeric. Yeah, it says right here in the docs, NaN in numeric arrays, none or NaN in object arrays, or NAT, not a time, in a time column. But isNA has a cousin called fillNA. So let's say we wanted to not just identify our missing values and get rid of them. If we wanted to fill all of the missing values with a specific same value, like fill the missing values with a mean or a median or the min, something like that, you'd use fill NA. Yeah, there's not a lot of nuance to is NA. It's a hammer. It's a nice Boolean. Fill NA has a couple of other options like, if we're filling NAs across the row or the column or all of them, etc. Yeah, glad you asked about that. So we got some clean data. Let's start exploring. And with our recipe, we're going to start nice and simple, univariate. So univariate, descriptive stats, frequencies, histograms, general getting to know you stuff. So with my first chart here, I'm outputting a histogram for a binary. So you should see very, very clearly, you know, of when we stack up the numbers, where was the biggest impact? Most folks didn't make it, right? That's our target variable. So that's what I want to look at first, right? If you want to get an understanding of the percentage, since this is a Boolean, you can call .mean on a Boolean or a 0-1 column. And we could look into the univariate statistics for more columns. If you have 100 columns, this might take a long time, right? But let's take a look at the proportions of first, second, and third class tickets. The human beings are not first, second, and third class, but we will say tickets here instead, right? The tickets are third class, not the human beings, right? Got to fix that in the curriculum. And I'm going to add a comment back up here that says stratification means we'll get even proportions of the target variable in each data set. Cool. All right. What else can we know? Let's check the distribution of ages. Not totally normal. A lot of youngins, not many teenagers, right? They're too cool for the Titanic. Glad they stayed home. Glad they were too cool. But then, yeah, lots of adults, and then it trails off. And this kind of makes sense because usually age is pretty normally distributed unless there's something crazy like a war or something like that. Fair has some outliers, pretty extreme outliers. The guy from the Monopoly game is paying to be on the Titanic. So some takeaways. Write down your takeaways. It's not just about making a pretty chart. Write down what the chart tells you in English. Predicting, so let's talk about this. If most people did not make it off of the Titanic, if we were to guess at random without a machine learning algorithm, what's most likely going to happen to anybody that was on the Titanic? They most likely didn't make it, unfortunately. That's what's called a baseline prediction. Your baseline prediction, we'll talk about this with modeling more. It's the best that you can do without a model. In so many words, usually with a categorical, it's usually the mode, the most frequently occurring option. Age looks normal-ish. Fair has some outliers. Survived can be treated like a category. And yeah, we can compare the proportions and anything else you want. Okay, I'm not going to dwell on the univariate because really our insights are going to come with bivariate. So I'm a big fan of scatter plots myself. Cat plots, bar plots, and box plots also help us help us visualize categorical variables with numerics. Here's something I want to share with you. A nice piece about a bar plot is that if we use bar plot on a binary column, we get a proportion. It's a nice to have. Whether if that column is zeros and ones or trues and falses, that bar plot will plot out the proportion. I'll show you what I mean. So let's visualize some of what I'm going to visualize here. I'm not visualizing every single combination of every single variable. You can certainly do that in your exploration. 100 charts, 800 charts in your slide deck isn't going to fly, but you might discover something. I definitely want to chart things with relation to the target variable. Definitely. That's the non-negotiable, right? So let's let's make a nice little bar plot. I made the advertisement that bar plot with your Y of the Boolean. So survived as our target. What we're getting is the proportion broken out. We get one column for each of the different classes of ticket. So, wow. This is like an advertisement to buy a first class ticket right here. Okay. The little whisker is a confidence interval. And the blue line here, that's the population survival rate. So second class ticket holders are doing a bit better than average. First class ticket holders are doing a much better than average survival rate. And third class ticket holders, unfortunately, are extras in the movie, right? Or the lead, right? So this is pretty clear to me that there is a difference here. If this was not crystal clear and we needed to be more confident, we could run a chi-squared. The survival is a binary categorical, and the first, second, or third class ticket are, we can treat those like categories with a chi-squared. So null hypothesis, survival and ticket class are independent. We know that they're not already, but let's run that. We reject the null hypothesis, and we have sufficient evidence to support the claim that surviving and what class of ticket somebody holds have a relationship. There is a relationship. We see that visually, but we can even take a look at that p-value. That p-value is really, really, really small, right? Super small. What about traveling alone versus survived? I've made it also a horizontal line for the population survival rate. And what I'm seeing here is it pays to travel with other people. It's actually a lifesaver to travel with other people, at least on the Titanic. We could keep running through other, again, if we weren't completely sure that these were different, we could run a chi-squared. Again, the chi-squared, set your alpha, specify your null hypothesis, use a crosstab of the two columns, categorical columns of interest, in this case, the target variable and whether or not they're traveling alone. Run the chi-squared, get the p-value, and if the p is low, you reject the null hypothesis. So we reject the null hypothesis that traveling alone and survival are independent. We see that visually, but even statistically, we don't have a lot of evidence to reject the claim that we don't have a lot of evidence to support the claim that they are independent. In fact, we have tons of evidence that they are dependent on each other. And we can keep on going, right? I like, this is one of the reasons, I'll plug it again, the bar chart makes it really nice to visualize two categories if one of your categories is a Boolean. It's kind of hard sometimes to make charts of categorical versus categorical if we have multiple categories. But if one of them is a Boolean, you can at least get some proportions with a bar chart. It's nice. Let's take a look at, let's keep going and see what the story of gender and survival looked like. So my column is female. So that's a 1 or a 0 for true or false. How I encoded this was manually rather than using the, I don't think I did the get dummies. I just manually made a column called this female. Population survival rate is just about 40%. And wow. That's a heck of a story, right? If for some reason that wasn't crystal clear and there was any doubt that there's a difference between those two bars, those two rates, run yourself a chi-squared. Okay. And what we're looking at least here, is categorical to categorical, where one of those categories is my y-axis is a Boolean, so I can get proportions visually. Kind of hard to visualize categorical to categorical without this. Shifting gears a little bit, let's talk about our numeric columns versus a categorical column. You bet your boots there's going to be some cat plots in here, probably some box plots as well. So first thing we want to do is set your confidence interval, 95%. That gives you your alpha. 1 minus confidence interval gives you your alpha. We'll select our appropriate test for our two variables. So if we're comparing numeric to numeric, we run a correlation test. If we're comparing proportions, chi-squared. And if we're comparing means, t-tests. So what I'm going to share with you is I'm going to pull a Mann-Whitney U-test. In your mind's eye, think of this just like a t-test. Mann-Whitney is a t-test that will work if your distributions and your data doesn't conform to the t-test assumptions. So I'll show you that this new fourth crazy test is not that crazy. So what I'm going to do is subset the data, right? I'm going to compare not survived to survived. So I'm making two different data frames, one for each, right? And then let's check the variances. Those variances are almost an order of magnitude difference, almost. So t-test is probably not the right tool for the job. Are the data science police going to come after you if you use a t-test on this? It's not the end of the world, but if the variances are almost an order of magnitude difference, I do want to see if I have a better tool. In this case, Mann-Whitney. Yeah, Andrew.
This test differ to the t-test when you run it with equal variance equals false. Which one would be better?
Short answer, I don't recall off the top of my head, but I will share, because I don't remember the mechanism of the equal variance underneath the t-test. I still think it's a t-test. It's not dropping into a Mann-Whitney test underneath the hood, but a Mann-Whitney test has, because it's based on less strict assumptions, it takes more of a signal in the noise to produce a low p-value. That's really, it's think of it as a more stringent test. If you go back to the original paper on the t-test paper, you'll know that was written by a brewer, right, at Guinness? Yeah, okay, cool. That t-test paper, all of that paper is basically proofs that the variances don't have to be perfectly equal, but in order of magnitude, I'm gonna pull a Mann-Whitney. Yeah, it's a more stringent test, so it takes more signal to get a low p-value. So if I just visualize these two things, the fair and the survival rate. So what we're looking at is the histogram of both of these. And I can't really tell very much from this histogram. The orange is on top of the blue. It kind of looks like there's more blue above the perished. So blue is survived, orange is perished. This seems to support the claim that the higher fare you pay, the more likely you are to survive. This is a great example for the visual is unclear, meaning visual is not going to make it to my final report, but I do need to run a hypothesis test. So let's talk about this hypothesis test. And before you start worrying about this Mann-Whitney thing, we do from SciPy import stats, define your null hypothesis in English, same thing with your alternative. And Mann-Whitney gives you back a p-value and a test statistic. Actually, I think that should be U. But here's the punchline that matters. If the p is low, you reject the null hypothesis. And what we do here, wow, we find evidence to reject the null hypothesis. And when we check the p-value, 4.6 times 10 to the negative 14th, that's pretty low. And this is with a test that's more stringent for low p-values. So definitely the case that the fare paid is different based on survive versus not survive folks. So what takeaways can we make so far? Well, it pays to travel first or second class, better to travel with family or company if you're going to be on the Titanic. Women are much more likely to survive, which goes in with what you hear in the movies, like women and children first, right? Survivors paid higher fares. And this also tracks with the class of ticket. We do have some other questions that I did not dive into in the bivariate. What's the relationship between the sibling spouse number and survived? What's the relationship between parch, fare, and age compared to survival? And again, if the visuals are not crystal clear, indicating that relationship, go ye forth with a hypothesis test and focus on your p-value. If I want to come back for a second draft on this one, if I've got time, are there any other variables we can combine together? Yes. Would it make sense to create new variables? Well, maybe. If we've got the time, we could make an is child variable. And just say if somebody's like, less than 18, less than 15 or something like that, we can say is child. you decide your cutoff point. Would it make sense to investigate each independent variable with each other and not only the target? Again, if you've got the time. Time is a pretty scarce resource, especially when folks want answers, right? What else do you notice? Write it down. And this begs the question, we're kind of limiting ourselves by looking at only 2 variables at a time. What are some other tools that we can use to look at multiple variables at a time? And I'll get into that, to share that with you. Let me check the chat here. Okay, cool. Yeah, thank you, Ryan. That is a good question. And yeah, the Mann-Whitney U-test, I don't know how to interpret the U on its own. It's just like the T statistic. You'd end up looking that up on a chart of T statistics if you didn't have a programming language. It's doing calculus. It's calculating area under a curve, right? So let's move into multivariate stats. So multiple different variables. You can make charts that have so many different variables that you can't figure out what's going on, but we often add additional dimensions to our data with color or with small multiples. Like if we have a category of 3 things, we can have 3 charts. Some really cool options. If you have many numeric columns, crank out a pair plot. You can even do a pair plot with a hue argument to introduce a categorical argument to the 2 numeric columns for a pair plot. Rel plots are the cat's pajamas because a rel plot could have lines, maybe scatter plots between a numeric and a numeric. And we could use hue or call for column to specify another category. And that's a lot of fun. So I want to share with you that multivariable, like 3-4 variable statistical tests exists, and we don't have time to get into it. So we just don't. But we can create subgroups based on our multiple categorical features and then peel those apart and do bivariate statistical tests. Enough talk. Show me a picture. What I'm going to show you right now is, here's my punchline. In each class of tickets, survivors tend to be younger. And what I'm looking at here is a box plot. My X is the class of ticket. So the 1, 2, 3 is the first, second, and third class ticket. Y is the age range. And so with our box plot, the box and whisker here, we see where the median is. That's the line through the middle. We see where the first and third quartile is. And now when I add a hue to this box plot, I have a blue and an orange for survived or not. And what we see here is that the across the board, the folks who survive, the orange here, tend to be younger in every class of ticket. So what we're doing with 3 variables here is we're diving deeper. We're not just looking at the overall age versus survived. We're looking at age versus class of ticket broken out by survived. What's that? Could I add?
No, I mean, would you get a better, plot? I mean, not plot, but better data if you added gender in there with this one? Like, how would that separate?
That we would be plotting 4 things. We totally, I can't remember if box plot has call. We might not be able to. So we have hue, which we can break out by a category, palette, orient. I don't see a way on box plot to add a 4th, because what would that be? Would that be a color? Would it be a shape? It's kind of, it's too many dimensions to put on this one plot. Yeah. On some scatter plots, we can do that, though. We can add 4 variables. Hey, look at that. So I'll show you what it looks like. Scatter plots are really nice. So I'm going to show you the picture, and then we'll talk about the code. What we're looking at right here is a scatter plot. So fare and age. Those are two new continuous columns. And what we're looking at is the fare to age broken out by the class of ticket, first, second, and third class, and whether or not people survived or not. And so in the legend here, survived is orange. So we see much more orange on the first class tickets. That tracks with what we saw earlier. And this is showing us, just like David was asking about, we are currently looking at 4 different variables. So 2 are numeric, the X and Y, and then the call and the hue are 2 more categorical columns. So this is a lot of power. And this is pretty easy to reason about. There's not too much noise on this chart, right? I really like looking at rel plot through this. And we could, if we didn't want to look at hue for survive, we could set hue to be another category, like gender, right? In fact, let's do that real quick. We lose the survived piece. Well, it's similar because the fare and the ages didn't change at all, right? We just changed the color of the hue here, so. Yeah. Let's keep going. Let's look at a bar plot. So bar plots, we can have an X, we can use a binary Y to get the proportions. And if we specify a hue, we can add a third dimension here. And now we're seeing of the first class ticket holders. So that's what this first 2 columns are. The orange is female and the blue is male, and the survival rate is on the Y axis. And so we see the survival rates are higher for first class ticket holders, but the punchline is that across all classes of ticket, women are likely to make it off the boat alive. Or make it to a lifeboat, right? And we can change our variables here, but by keeping my target variable, at least if it's a binary, keeping my binary target variable, this bar plot's pretty interpretable, right? That's not bad. What did you learn at Code Up today? I learned how to visualize 4 and 3 dimensions on one graph. That's pretty cool stuff. We could continue to drill down deeper and deeper and deeper. And this is why I made a lot of talk of making subsets of your data so we can create subsets. And what we can do here is say, let's make a subset, women in third class with third class tickets, men with third class tickets. We've subsetted those down. And we could provide some comparison. So overall survival rate, 40%, overall female survival rate, 75%, overall male survival rate, about 20%. And then we could break this out by subgroups as well. And again, I'm going to show you a 4-dimensional plot here. So I have X as my class, so 1, 2, 3 for the first, second, and third class. I have alone as the color coordination here. And so we have 1, 2, I lied to you, I have 3 dimensions here, and then the survival rate. So we see, again, first class ticket holders doing pretty well on the boat. But at all ticket classes, if somebody's traveling alone, the chances are worse. So whatever you do, before your next time you travel, run your analysis on Titanic. Whenever we make a model, though, we're assuming that the future data, that the other variables are similar to what we encountered, right? So write down your takeaways. As soon as you have some takeaways to write them down so you don't forget them. And then you may have other questions at that point. If we wanted to peel this apart, so looking at survived, class of ticket, and alone, or broken out by gender, class of ticket, and survived, here's the way to run. I'm going to show you right now how to run a statistical test, a hypothesis test, when you have 3 variables of interest. The first thing you do is not statistical. The first thing you do is you create two subgroups, right? In this case, we'll break this out based on gender. So we have a male subset and a female subset. And then we can run 2 different, in this case, chi-squared, because class and survived are categorical. What I'm going to do is run a chi-squared on the female subset of survived, the female subset of class. And what do we find? We reject the null hypothesis that class of ticket and survived are unrelated. That makes sense because they're totally related. We saw that visually. And then looking into the male subset. So here's how we can get 3 variables. You subset your data frames and then run tests. That's a lot easier than getting too fancy. And we reject the null hypothesis that survival and P-class are independent for male set passengers. So regardless of gender, the class of ticket and the survival are in fact quite related. Yeah. Further up.
On this one, could you have the column in there with males, female? On that?
To cat plot?
Yes.
Let's see. We could answer that question by trying it out, maybe getting an error, or we can check the docs. Ooh. That looks promising, David. I'm digging your curiosity here. Let's do it. Let's do a call here. And you said you wanted to break out on gender, right? Yep, you got it. Error message, it's because I forgot a comma. Yeah, there you go. Look at that. Isn't it though? Yeah. This is really the power of small multiples of multiple charts takes the place of a 4th dimension a lot of times, or an nth dimension. There's some other.
Would you mind repeating that again, please?
Yes. When you have a column argument to a Seaborn function that takes one, you can have 1 column per possibility. So right now, David asked if I would show is female for the column. So on the right-hand side, the right-hand chart is survival rate by class of ticket, by if they're traveling alone for women. So we have X is class, Y is survival, and alone or not is a 3rd variable or a 3rd dimension. And because we're comparing this female to not, we have a 4th dimension, which is really nice because it's, even if we were doing 3-dimensional charts, they'd be very hard to wrap our minds around, or just visually. But having something called small multiples, so multiple charts, can take the place of adding another dimension. It's really quite powerful. And in fact, lots of small charts can add a time dimension. That's how animation works, right? You have X and Y pixels, and if you put them in order across time, you make a little flip book. In fact, that's what Galileo Galilei did, tracking sunspots across the sun. Did y'all hear about that? Really cool. Check this out. Maybe this is a GIF. No? There we go. So Galileo Galilei Galileo turned the telescope from a tool of war and intelligence to a tool of science, and pointed his telescope at the sun and didn't go blind. He pointed the telescope at the moon and Jupiter, and discovered Jupiter's moons. The church loved him. What's going on with these panels right here? Each frame of this panel is it's a copper plate. So he took his telescope, pointed it at a copper plate, and noticed that there were spots on the sun, and would do the whatever chemical process necessary to burn the plate for that day, burned up late for another day. I think this is, and you see in the lower right-hand side, some numbers. I think those numbers are days in the month, if I'm not mistaken. So in this way, time is a dimension for a two-dimensional bunch of pixels. And Galileo didn't animate these things. He put all of these plates in space, adjacent in space. Yeah, he created Pixar. That's right. Yeah, and here's a small multiple that's not animated, right? Pretty wild stuff, right? What'd you learn in data science today? Galileo. Oh my gosh, yeah. And he's got 3 dimensions going on. The X pixels, the Y pixels. He wasn't thinking in pixels, but he's got the X measurements, the Y measurements, and then time is the 3rd dimension. So what we can do with the call argument, I wouldn't do this necessarily with time because we don't have time in this data, but we can break out the call. And it doesn't have to only be limited to a binary. In this data set, we have other options. What did we have? SIB SP. We'll get 1 chart for each SIB SP. Now, this tells us we don't have very many options for the SIBS 5. And yeah, we only see if somebody's alone on if SIBS is 0. So this particular chart isn't that useful. But if you have multiple categories, well, by gum, folks, I want to tell you, you can get 4 variables on 1 chart and not lose your mind. We could jam more variables on here with the X's and O's or the size. That gets really hard to reason about. Pretty wild, huh? Thank you for bringing that up. Thank you for bringing that up, David. Yeah, majority of lifeboats being on first class deck. Yeah, Bert, I didn't know that off the top of my head. And yeah, I figured life is really interesting. It's worth nerding about, Arsene. Let's see. That's the end of the code. So like, what do you do now? You get creative. Get creative. And if the Seaborn function that you're using doesn't have a call argument, see if you can find its figure level version that does have a call argument or a queue. Get creative, get curious. There's no substitute on the planet for human curiosity and human ingenuity. We are amazing creatures. What's the relationship between survival and parch for women travelers, male travelers? What's the relationship between the SIBS value and survival based on gender or some other category? Whatever subgroups you can create and visualize, do it. What variables have you not looked at yet? What other subgroups can you test? And you can make subgroups of subgroups. We did that just a minute ago. And if you have, I'm sorry?
If you're a rich man or a poor one, you have about the same percentage chance of surviving.
Yeah. I mean, this is the hello world. Titanic data set is the hello world. You're not gonna win a lot of brownie points in an interview talking about how you worked with Titanic data, because I was like, everybody's done Titanic data. But this recipe, take this recipe and the Seaborn charts here and throw them at your telco data, throw them at other data sets, and get curious. There's really no substitute for getting curious. Here's the thing though, we can get so curious that we miss the minimum viable product, because it gets so easy to get lost in the data. So write down your takeaways and work fast. Mash that B button and run forward like Mario to get to your minimum viable product. Because if you've got an MVP to show, your stakeholders are more likely to give you more time to perfect it than like, hey, it's been 4 weeks. Do you have any insights for me? Like, it's been literally 2 paychecks. Do you have anything to show for your work? Race to your MVP. And then you have a much higher likelihood of making a pitch for more time, as opposed to like, well, I'm gonna get the book out the door, but I gotta get the first chapter done. Are y'all with me on the MVP thing? Cool. And if you have time for a second draft, revisit some of the things that you may have skipped earlier. You might want to handle your nulls a little differently, might explore creating your own features, and get after it. All right, yeah, it's easy to get lost in the sauce. We can get really nerdy about our tools sometimes too, right? But customers don't care about the drill that you're using, they care about what it can do. They care about holes, not drills, right? Mindy, you have a question?
Yeah, this is actually like kind of going back to the beginning of the lecture, but you gave us that really great tool to see what percentage of nulls you have. And I know this is going to vary depending on a bunch of situations, but just in general, is there like a cutoff? Like if you have more than, I don't know, 20% nulls in the call, like what would be like, definitely just drop it and don't try to do anything else with it at that point?
I would say if a column is 77% null, it's basically garbage. In the sense though, sometimes depending on what the data is measuring, your column that is lots of nulls may not be something like a deck here. It may be something like a free answer, like a text answer on a survey. Maybe the survey, you've got required answers for like 1 through 10 on a survey, but the text answer is not required. So in that case, we wouldn't necessarily drop it, but we would want to investigate that a little more completely. I don't have a hard and fast rule for when you drop things, but this deck column, nearly 80% is missing. It's not some optional piece of the data like a free answer on a survey could be. I'd drop that for sure. This nearly 20% of the age column being missing, in an effort to race to the visualization and the statistical test, I removed the rows that had missing age. In this case, 20%, let's talk about this. If you've got 20% of your column is missing, and you can't just delete it because you don't have that many rows to begin with. Titanic doesn't have thousands and thousands of rows, just some hundreds, right? In this case, we could, a simple approach would be to fill NA on age with the average or the median. The median might be a little better option. Or if you had any, I'm adding some layers to my answer here. I hope that's okay. If you had any information about the domain, like, I don't know where we would find this information, but if for some reason we read somewhere that on the Titanic, if somebody was under 5, that they didn't write down the age, then we could just plug in 5 here. If we had that domain knowledge. Something that can happen is if we fill, and this is why there's not one answer for handling nulls. It's a good habit to fill your nulls if you don't have any better tool with the median or the mode if it's categorical. But what that can do is overweight the median or overweight the mode, which is already prevalent. A more sophisticated answer, and this is like a third draft kind of an answer, would be to make age your target variable and make a regression project, not even a project, but just some regression code to see, is there similarities about the rows with age missing? Like, are all of the other columns very similar? Because there could be another story going on in there. Like if a family member was under 10, or if all of these people with missing age, if there's something else in the story, we might be able to suss out something more clever or more insightful to do. And I'll see if I can't chase this a little bit. You want me to riff on this a little bit?
Yes.
Let's riff on this a little bit. Let's investigate the rows with missing age. Now, we can investigate this statistically, visually, whatever. So we'll say missing age rows, and this will be, I'm looking at the entire data frame right now because we want to handle our nulls before we split. And so I'll say df where df.age is NA. There's our is NA friend again. And we can say, let's get to know missing age a little bit more. Series object.
You forgot the N, you got the N and the S, yeah.
I was answering the question, where are you transmitting live from? I'm NSA, is NA. Okay, I already handled those nulls. So I'm gonna have to go back and run my code again. Run my code again, and okay. Now this is very interesting. We have 177 rows with missing age. And we could compare this to age present. And this would be df where not, so we'll say df.age is NA, not, that's what that tilde is a negation. And so let's compare these two things just a little bit. Now, the head is just going to give me a sense of a couple of rows. But what if we wanted to say age present dot survive? Let's look at this. Survived dot value counts. Let's look at that through. Actually, let's do a hist visually. Or even actually value counts. I think we could do normalize equals true to get the percentages there. And then we can compare this to missing age dot survived dot value counts, normalize true. Interesting. So the folks where we have missing age from 60% not surviving, and let's compare this to our population. So df.survived.value counts, normalize true. So we're normalizing so we get percentages. So the population overall perish rate is 61%. It seems like the rows where age is present, that's similar. And where rows where the age is missing is 70% perished. So there might be something curious going on. There might be another story. So let's do age. Maybe do df dot the class of ticket. Yeah, p class dot value counts. It's true. And there's, I mean, this is what I mean about getting curious. You zoom in on a thing, make a subset, make another subset, keep on zooming. Okay, so that's overall. And then we'll do, copy the same thing. And let's take a look at missing age. Okay. Ooh. Okay. Age, what is it? Age present. Interesting. What are y'all seeing so far? A lot of that missing is third class ticket holders, and they perished at a higher rate, which is tracks with the third class ticket holders. Mindy, I see you've got your hand up. Go ahead.
I was just, okay. I thought in like yesterday that we talked about not like splitting the data first and then just like doing this on your train set and then having that for the other two sets as well. So I'm just a little confused on why we're.
I'm certainly not trying to give you conflicting information. I feel comfortable doing what I'm doing right now because I'm only looking at one variable at a time.
Okay.
Basically, if you have a 2 dimensions, I realize I'm looking at multiple different columns, but I'm not really looking at how they interact with each other. And another reason why I feel comfortable doing this is in service of trying to understand the nulls that we want to handle before splitting.
Okay. Okay.
We are getting into a gray area. I will admit that because I'm really diving pretty deep on some univariate, and I'm doing univariates next to each other. So we're getting kind of gray here. Yeah.
Like when we did the imputer yesterday, would that be instead of this or in addition to if you used that?
Imputer is going to be a lot quicker yeah. Yeah, and it's cool to use an imputer before the split. Absolutely. Yeah, diving this deep, I am running the risk of getting to know a little bit too much about the entire data set. But this is in service to trying to figure out where is 20%. If I don't want to lose 20% of my data if I can help it. Yeah. Cool. So in this case, we could keep diving and chasing this a little deeper and deeper. A much more sophisticated approach could be to make a predictive algorithm, a regression, since age is continuous, basically. And we can predict age based on every feature. And here, I'm kind of coming to the conclusion that third-class passengers with no age, it seems like nobody cared enough to write down their age. That's my best guess right now. Arsene?
Yeah, I was rather thinking that maybe people who had a third class ticket were not literate, so they may not have known their age or something like that.
Yeah. Yeah, if they're signing an X on the signature, they might not have filled out the age
Yeah.
proportion. Yeah, good point. Yeah, good point.
Yeah, but I think it was, even though it was a gray area, I think it's really interesting to see how like a null or non value can have an impact on the whole data if we can dig into it.
Correct, because if I just threw the average age of 20 at everybody, that might not be representative for filling these nulls. So this kind of all spilled out of Mindy's very thoughtful question of, is there a rule or some guidance here? And the answer is there's not really a hard and fast rule, but you know it when you see it. Nearly 80% missing, drop the column unless it's something that's like optional as part of a, optional free answer or something like that. But with age, I don't want to lose 20%. I don't want to drop 20% of my rows, nor do I want to drop the age column. So it can be worth looking into more deeply if you've got the time. Hashtag second version, second draft, right? Yeah, I'm catching up with the chat here. Ryan Miller, could we make a Boolean out of has deck or not? Absolutely, we could. Yeah, DiCaprio's messing with our data. And yes, Lachlan, that is the case. I was diving in deeper to understand what's the story with age missing. And I think Arsene's hypothesis has some legs to it. And Adam is contributing. We can peek under the hood a bit to get a sense of how we might handle nulls, clean the data. Suppose we start noticing some relationships, that's okay. What happens when we rely on statistical tests and are trained to be confident enough to make the claim perfect? Yep. When we start noticing trends before fitting, we will just confirm those trends anyway, yeah. This is basically the raw form of Tableau. I mean, I'm getting my hands directly on the data, which I like myself.
I just thought about that. I was like, since the names are on there, you can't really tell if they could sign their name or not. It's just a passenger ID.
Yeah. There are some data sets where you have the passenger name. Lord Chesterton or whatever is on there.
Without that data, you wouldn't really know if they were.
Yeah. True. Great discussion. Very, very rich discussion. And I think I started nerding out on the missing age data, but keep your nerding out if you can, because if you can, try to keep that to the second draft so you just get something to show for your work. That's a strategy for making sure you get more work. Cool. Great conversation. Thank you for engaging with that. And that's really speaks to the point of get creative. And And this is driving home that there's not one answer for handling nulls. If there were, it would just already be part of a function that magically did it, and we wouldn't have to talk about handling nulls. It would just be like, oh, 17%, that's your cutoff point. Really depends on the data itself and where that data is coming from. We'd love to do statistical analysis and make models on like predicting, like investigating like incoming students. But incoming students, where you have like the conversations with admissions about why you want to be a data scientist, those are optional. So there's a lot of nulls for people that didn't have that conversation. They like made an application and then they just ghosted, right? Same thing with like a free answer on a survey. Sometimes you do have data that you don't want to get rid of, but you might just need to do something manually sometimes. Yeah. But work fast to get to your MVP before you chase too many rabbits. And with that, folks, we will move presently into the exercises. The first exercise set is the IRIS database. Second exercise set is Titanic. And if you really want to get the most bang for your buck time-wise, you can go dive into Telco first, since Telco will be the project. Okay, that's what I've got for you. Great discussion. And let's take a little break, bio break, and get working.